Hello everyone. After some time, we have completed the first part of our study. Today we will start with the second part. The first topic of the second part is about routing between data centers. Just by looking at the title, you wouldn't know the meaning of this topic. So let's first take a look at the overall topology. In the topology, we expect that BR1 and BR2 prefer to access the data center and give priority to DC2. BR2 accesses the data center, giving priority to DC. Considering the real-world scenario, what kind of situation is it? Let's assume DC1 is a data center in Europe, and DC2 is a data center in Asia. BR2 is a branch office in Europe. Relatively speaking, from a geographical standpoint, it makes more sense for BR2 to prefer the European data center. Access is more reasonable. BR1 is a branch office in Asia, so it's more logical to access the Asian data center. Therefore, in this scenario, it's necessary to choose between data centers. In this scenario, we will implement routing between data centers. Switch to the experimental scenario to select a configuration policy. Here we plan to create a centralized policy, guiding the route via the next hop. Preferentially select a data center and create policies. Please note, last lesson when introducing policies, specifically mention site list, VPN lists, and TLOC and other such lists. Generally speaking, we need to create them in advance. If you are a network planner, create them in advance. In this experiment, observe TLOC. Last lesson, I created TLOC for DC1. It has Edge 1 and Edge 2. Each edge has 2 links. Next, I'll create DC2. DC2 has an internet line. Selecting the default IPsec encapsulation. Please note, number 6 is the system ID. It also has an MS line using the default IPsec encapsulation for saving. Here we have 2 TLOC lists. When routing, TLOC can serve as the next hop, setting its priority through set to guide our branches to access the data center. Name it. Note that we're adding TLOC. Satisfying the criteria from the site. Observe the topology BR1 accesses DC2. You can also define different colors. Here I'm starting over to recreate. What I added isn't TLOC, it should be routing entries targeted towards the site, starting with BL1, VPN 10 for BL1. Good. When matching the site and VPN, our action is to give it a TLOC, preferring it to DC2. It should be a priority. Setting its priority to 50. DC2's preference is prioritized. This is the first, then creating another policy for DC2's preference. Click on bar 2 again. We operate on call VPN. When they match, there's an option for TLOC. Assigning to TLOC for DC1. Its preference is 50. Previously, a default wasn't modified. We'll come back and modify it later. My TLOC is already set. Next step, no options. Preference for DC2 is set, adding a site. The site for DC2 comes from BR1. Scroll down, keep going. If you scroll down, there's another one for DC1. DC1 is BR2, need to adjust it. For DC2, it's outbound BR2. The display requires some scrolling here. Let's check the routes coming from BR2 again. The outbound route should go to DC1. The outbound from BR1 should go to DC2, no problem. We've successfully set up preferred routing in the data centers. Now, let's activate this policy. Let's review the configuration. The configuration generated for the routers. Let's find the policy we see here. For VPNs, the site list is mentioned later. It will prefer DC1. This one prefers DC2. 6.6 sites are 110 and 120, BR1, BR2. These are the prefixes. This is the encapsulation type. Then apply the policy to BR1 and BR2 on the outbound, no problem. Activating, please wait. Next, we need to go to the DC to check our DC routing for correct propagation. First, check inside the device. BR, it received the routes. Receiving routes in VPN. Apply filtering. Please continue watching. Now, I'll remove some unnecessary information. Removing the tenant, hard. This is the default route, not considering the path to our topology. Again, VPN 10 is 40. Find the routes for 40. VPN 10 is 40. BR3 received the route 192.168.40. It seems there wasn't a switch. Let's check in the command line. Everyone sees that the path to 40 is via 6. 6.6, look at BR2. It's supposed to prefer the DC. Both Topology's default route also has 2 talks. I've checked the OMP routes. I found that there is no priority set here. So we need to adjust the body again. It's common to cancel before making updates, usually cancel first and then update again. You can do it all at once, but it's not recommended to design it this way. Adjusting the policy. Options for DC1 and DC2. The default behavior is to accept, and here's the list 50. Side list. Preferring DC1 save. DC2. I had set the site as priority. Instead of our TLOC, I'll make an adjustment for DC1. I've already adjusted for DC1. And for DC2, we need to set the priority for TLOC. Not outside, TLOC. TLOC selection is 12. Save and update the policy again. After the update, reactivate. Validating the routes. This is BR1. BR1 prefers DC2. Its priority has been set. Good DC2. When it goes to the DC, it will prefer this site as DC2. Observe BR4 222222444. It's very clear OMP's preferred attribute is 50. It prefers the 2C edge incoming to DC2. This is routing between data centers. The application scenario is a branch of its choosing the nearest data center for access. Okay, that's the end of this lesson. Thank you.